This time, we will talk about another application of differential equation. So, we know how differential equation is applicable and useful, no, in problems, so many problems. Even in the problems that in our real life, we can also apply differential equation for us to solve. So previously, the last group, they discussed about the mixing model. So this time, we will talk about rate of change of a system. So later on, we will show you a example problems involving rate of change of a system. So when you say rate of change, no, when we hear the word rate, what comes to our mind is that something that is related to time. So many problems involving rate of change, we will deal with time. So accordingly, the definitions that we have, it is how fast something is changing. It may be changing of distance, changing of volume, changing of pressure, or etc. And we can determine in which changing with respect to time, reduce or the other. So rate of change of a system can be determined in two terms. First one is that it can be expressed in terms of another variable, or it can also express in terms of rate of change of another variable. That means it requires derivative. That is why in this kind of specific topic, which is rate of change of a system, we have to recall what we have learned in our previous mathematics, or specifically calculus, the differentiation rule, anti-differentiation, implicit differentiation. So anyway, rate of change, we are just concerned how the other, for example, if one part of that system is changing, let us say decreasing or increasing, so what will happen to other part or side? So there is an effect to that part. So that is what we are going to do. So without any further ado, let's get started. So let us proceed to our example. So this example is for you or for us to get an overview on how to deal with this kind of problems involving rate of change of a system. So just like what I have mentioned earlier, that we are just concerned about the rate of change of the other part of that system if one part of that system is changing. So for example, just refer to the illustration that is being shown in the PowerPoint or presentation. So the problem there is that, for example, if there is a perfectly spherical balloon and you start to inflate that balloon, and then the radius of the balloon became 15 inches. So when you stop inflating the balloon, its radius became 15 inches, right? So when you continue inflating the balloon, the radius of the balloon is increasing at constant rate of let us say 0.5 inch per seconds, which is rate is equals to 0.5 inch per seconds. That is the rate, or how fast is the radius of the balloon is increasing when you begin to inflate the balloon again. But that means if the radius of the balloon is increasing, that means that the surface area also of the balloon is increasing. How fast? That is, we don't know. That is what we are going to find. The rate, or how fast is the surface or area of the balloon is increasing. Now, in this kind of problems, we don't have the exact equation or formula that we have to use when we are dealing with problems involving rate of change. It is because it depends on what kind of problems you are solving. For example, for instance, in this problem we have a sphere. So we should know the formula for the surface area of this sphere. So as we know, the formula for the surface area of the sphere is 1 S is equals to 4 pi r squared. That is the formula for finding the surface area of this sphere, because we assume that our balloon is perfectly spherical, right? Now, we have to find equation that can relate to our variable, which is in this time we only have two variables, the variable r and variable s, right? And exactly in our equation we only have s and r, so we can easily derive, no? So there is no specific equation, but there is a standard procedure that we can apply or we can follow step by step for us to solve easily the problem. So the first step that we are going to do after we have this formula of the square is to apply implicit differentiation. That is to derive both sides. So let us say d over dt of s, and to the other side d over dt of the other side. So take note that we are using the variable t because the function r and the function s are all function of time. It is because they are all changing, increasing with respect to time. That is why instead of x, we are using the variable t. So by continuing solving this problem, the derivative of s with respect to time, it will become ds over dt is equal to, we have to derive this the other side. So 4r squared will become 8 pi r dr over dt. Okay, so it became 8 pi r dr over dt. Now take note that we already have the value of dr over dt, which is the change of rate with respect to time. That is 0.5 inch per second. But we have to find the value of change of system, I mean change of surface area of the balloon with respect to time. So by continuing solving this problem, so take note that we have the value for r, dr over dt, and we also have the value for r, which is the radius of the sphere. So by this, by plugging to our calculator, the 8 times pi times 15, because 8 pi r is 15 because that is the radius of the sphere, and dr over dt, the change of rate or radius of the balloon, is 0.5. So we have 60 pi. So the rate, that means that as you begin or inflate the balloon at the constant rate of 0.5, its radius is increasing at the rate of 0.5. Its surface area also is increasing, changing with respect to time at constant rate or at the rate of 60 pi. So that is how we can apply differential equation for this system. In this system, we already have the one rate or one quantity, and we are finding for another quantity. Because in the system, one part of the system is changing, there is an effect to other side or part. So that is, we can apply differential equation. So let us proceed to another example, the word problem. So we can apply differential equation. So let us proceed to the example number 1. So as you can see, this example is not similar to the previous example that we solved. That is why there is no specific equation. But we have to follow the standard procedure that is for us to solve or follow the concept easily. So in this problem, it says that a 13-foot ladder is leaning against the wall. A 13-foot ladder is leaning against the wall. Now, when the base of the ladder begins to slide from the floor to the floor at the constant rate of 5 feet per second, the question is how fast is the changing or rate of the top of the ladder is leaning downward, into the floor. So that is what we are going to find, the value of change of top of the ladder. So we can solve it. No? We can solve by the application of differential equation. So before we solve this problem, just in this kind of problems, which is word problems, we have to analyze. We have to be an analytical thinker. Because problems involving rate of change is mostly worded problem. So the most or the best method for this kind of problems is that to draw or to sketch the problem or the situation, because that will help you a lot for you to imagine, for you to see what we are going to or what you need to do. So in this problem, as you can see, as you can notice, the ladder, the wall, the floor, the combination of the three form a right triangle, right? This ladder, the floor, and the wall form a right triangle. A right triangle. So let us assume that the ladder or the distance or dimension of the ladder is our hypotenuse, which is 13 feet or 13 foot. 13. And also the distance of the base of the ladder from the wall is 12 feet, which serve as our adjacent. So we have to recall our knowledge in trigonometry. This is the adjacent, this is the hypotenuse, and this is the opposite. The opposite is always opposite of our angle. That is why it is called as opposite. The adjacent, the hypotenuse, which is the opposite of the right angle, which is the 90 degrees. So, in this kind of problem, we know that we will deal with a triangle. So, we should know the equations in right triangle. So, it's either SOHCAHTOA or Pythagorean theorem. So, in this problem, we are going to use Pythagorean theorem just for us to find the value of y. Because we don't know how or what is the distance of the top of the ladder to the floor. So by using Pythagorean theorem, we can easily solve. So how? So we know that the formula for the Pythagorean theorem is x squared plus y squared is equals to our hypotenuse, which is 13 squared. So we are looking for the value of y. So what we need to do is to transpose the variable x to the other side. So it will become y squared is equal to 13 squared minus x squared. And then we know that our x, we already have the value of x, which is 12, which is the distance from the base of the ladder to the wall. So by calculating it using our calculator, we have 13 squared minus 12 squared. We have y is equals to 13 squared minus 12 squared. We have 25 and square root of 25 because our y squared, it will become 5. So meaning the value of y or the distance of the top of the ladder to the floor is 5 feet. So we have the value of our distance. Now, but this is not we are looking for. This is just the distance, but we are looking for the rate. No? How fast is the top of the ladder is leaning down to the floor. So we all have the information that we need. So just like what we did to the examples, we have to follow that one, which is, so we use the formula for the Pythagorean theorem. So for us to find the value of dy over dx or dt, we have x squared plus y squared is equal to 13 squared. The Pythagorean theorem formula. Now, just like what we did, we have to differentiate both sides, no? For us to find or to find two variables that will or that can relate to our variables in this kind of problems. So we know that derivative of x squared, it will become 2x. So derivative of x squared, it will become dx over dt. Again, take note that we are using the time because they are all changing with respect to time. So dx over dt of 2x plus 2y and dy over dt. Okay, so we have already the value of dx over dt. It means the change of x, x with respect to time is 5 feet per second. And how about dy over dt? The change of y. The change of y with respect to time. So we have to divide them. So just like what we have, or we can apply the previous topic that we learned in our differential equation. So we have to divide them into 2y. That is for us to get the value of dy over dt, because we already have the value of dx over dt. So by cancel out, it will become dx over dt times x, because it will cancel x over y plus dy, the change of y with respect to time, which is equals to 0, because remember that we are using the formula for the Pythagorean theorem. So by transposing this into other side, we can get the value of dy over dt. So we have dy over dt is equals to negative x over y times dx over dt. So we can easily solve it because we already have the value of this one. So by calculating it by plugging it into our calculator, we have dx over dt. We have negative the value for x. We have the value of x, which is 12. The value for our x is negative 12 over our y. We know that y is 5 feet, right? So we have 12 over 5 multiplied by dx over dt, the change of rate, change of or rate of x with respect to time is 5 feet per second. So we have here negative 12 feet per second. So in conclusion, as the base of the ladder begins to slide away from the wall at the constant rate of 5 feet per second, its top or the top of this ladder is decreasing at the constant rate of negative 12 feet per second. Now, take note that we have the value of negative 12 feet per second because as time passes, the distance from the top of the ladder to the floor is decreasing, right? So that means while it became short, so that is why we have the value negative. So negative 12 feet per second. Now, this is our concern, how this system, for example, in this ladder problem, we have the system of this ladder, and its base is changing. So what is the effect? What is its effect to the top? So it is also changing at a rate or constant rate. So we have negative 12 feet per second. So as you can see, we applied differential equation. So that is why differential equation is very important. We can solve even difficult problems or problems by applying differential equation. So to discuss or to give us a further information about rate of change, here is one of our classmates to continue and to give us another example or last example. That is for us to give a further explanation about this topic, which is rate of change of system.
So problem number 2, water flows into a conical tank at a rate of 9 cubic feet per minute. How fast is the water level rising when the water is 6 feet deep? The volume of a cone, height and radius r is V is equals to 1/3 pi r squared times height. The water in the tank forms a volume V and height. So volume and height are both functions of time. So we know that the rate of change of volume with respect to time is 9 feet. dt is equals to 9 feet 9 feet per minute. So we need to find the rate of change of height with respect to time at the instant height of 6 feet. So since ang shape ng problem natin is a cone, so ang formula na gagamitin natin is V is equals to 1/3 pi r squared times h. So since we have three variables, yung V at saka height is related naman siya sa ano. So to find the value of r in terms of height by using a similar rectangle. So if you are going to look at this figure, we have two rectangles. Nakabuo tayo ng dalawang rectangles. Yung rectangle sa conical tank at saka yung rectangle sa water. So, by using ratio and proportion, makukuha natin yung value ng R. So, 5 R is 10 H. So 5/10 is equals to R over H. So cross multiplication, 5H is equals to 10R. So divided by both sides by 10 cancel. R is equals to H over 2. So, yung nakuha natin yung value ng R, which is H over 2. So, ipapalit natin dito sa formula ng volume. V is equals to 1/3 pi, then H over simplify the formula of the volume, i-multiply natin siya. So, h over 2 squared is equals to h squared over 4. So, 4 times 3 is 12. So, pi h squared times the height is equals to q over 12. So, v is equals to, mag-derive tayo, yung exponent, ibababa dito, 3 pi h squared divided by 12. So, cancel. Ang mangyayari, v is equals to pi h squared over 4. Formula, we have to differentiate both sides with respect to time. D over dt multiplied by volume is equals to d over dt multiplied by pi h squared over 4. Ang mangyayari, dv is equals to dt a over dt. So, pi h squared over 4 times dh, or the rate of change of height with respect to time. Since given rate of change of volume with respect to time, which is 9 feet, so sunod natin dito, 9 feet is equals to pi, ang height natin is 6 feet squared over 4 dh over dt. So, 9 is equals to pi 36 over 4. The rate of change of height with respect to time. So, 36 divided by 4 is 9. So, 9 is equals to pi over 9 dh over dt. To find the rate of change of height with respect to time, divided both sides by pi 9. So, cancel. The rate of change of height with respect to time is equals to 1 over pi feet per minute. And conclusion, the water